Alright, so then I had left this one, I mentioned this one a while ago, but I thought I'd formally put it in the slideshow. Atomic mass unit is abbreviated AMU. It's a special unit we use to measure the mass of subatomic particles, protons, neutrons, electrons. I will tell you, if you're a biology major, they have given Dalton credit now for this unit, and so now you can hear these things instead of being called AMUs, they'll be called Daltons. So in your biology book, sometimes you'll be reading about Daltons, and so this unit AMU has been given the name Dalton now. Also, this is what's called atomic mass unit. This is our abbreviation, but scientists have gotten really, that's also called a Dalton, really gotten lazy. That's the word, that's the abbreviation, or they have an abbreviation for this abbreviation. So sometimes it's just the letter U. So as you're reading a problem, you'll see maybe like 15.999 U. That is atomic mass unit as well. AMU, Dalton, all the same thing. It is just your protons, neutrons added together. All right. So then we come up with atomic mass, and a lot of students get this mixed up with mass number. Many of you were taught in middle school that on your periodic table that this is the mass number, and this is actually not the mass number. This is the atomic mass. Why is this different? Because this is an average. This is an average of the isotopes that we know exist for different elements. So this is not the mass number. Mass number is specific for one single atom, and sometimes it'll match this and sometimes it will not match it at all. So don't ever just use this number for now while we're doing mass number and number of neutrons, because sometimes it will not match. Later we'll use this number because we will be using the average when we do molar mass. Okay, so this is an average of the isotopes that we exist, and so we're going to learn how to calculate this particular number as where this comes from. So I just wanted to show you on chlorine as an example. So this is the atomic number, and when we look on the periodic table, that one you can always count on for chlorine. Chlorine's not going to change. If you change it to a different number, you get a different element. So remember that chlorine's always going to have 17 protons. That's the only number you can ever count on. It doesn't always have 17 electrons, and it doesn't always have 17. In fact, rarely does it even have 17 neutrons. So that's the only number we really can count on. The periodic table is the number of protons. Alright, so I wanted to show you this. This is chlorine. Chlorine actually has two, and if we go back to that thing that we see off the periodic table there, it actually has two isotopes. We have this isotope, which is chlorine 35. Okay, how am I getting 35? Well, I add the protons and the neutrons together and I get 35. So this particular atom has a mass number of 35, but this is another atom of chlorine, and this guy's mass is 37, and this is an isotope of chlorine. So, but why doesn't this say 37? Well, again, this is an average, and it goes for what we call the percentage abundance. It's kind of like if I were averaging grades, and say you made a 100 on homework, but you made a 60 on a test, your average would not be an 80 because homeworks don't count as much as tests do. So if you'll notice, the average, this is 77% of the isotopes that we know exist for chlorine are chlorine 35. So this number is a lot closer to 35 than it is 37 because of the abundance that we know. Now, have we counted every single atom of chlorine? Absolutely not. We've just done sampling, and for the samplings, this is what we call the percent abundance. And some elements have 2 isotopes, some have 3, 4 isotopes, some have 5, 6, 7 isotopes. Some just have 1 isotope. So, and I guess it wouldn't really be an isotope then, but it's a type. So again, the only thing making it different is those number of neutrons. It's not the protons, it's not the electrons. So that number there is the atomic mass, and we're going to learn how to calculate the atomic mass, and I'm going to do 4 examples with you. Okay, so first I'm going to do this one, and then I'm going to do the other ones that are actually on the PowerPoint. Alright, so this is how you're going to do it. You're going to change your percent to a decimal, okay? And how do you change your percent to a decimal? You move your decimal over 2 places to the left, or you divide by 100, either one. So we're going to change these numbers to decimals, and then we're going to multiply them by their masses. And then we're simply going to add those numbers together. For this particular one, there are 2 isotopes. I'm going to switch, see if I can get down here onto a blank page. All right. So this particular one, we have 2 isotopes. So I'm going to do 2 parentheses here. And I'm going to put a plus sign in between. Sometimes these are so easy and students will make mistakes because they won't put a plus sign in between. Okay. And so then I'm going to start out with, it doesn't matter if you start with the percentage or if you start with the mass. We'll go ahead and start with the mass. This one has a mass of 35 AMU. So let me go ahead and put AMU or U. And I'm going to multiply that by this percent. But I'm going to change this percent to a decimal. And so you get 0.7735. And I don't need anything behind it because I've changed it to a decimal. And then this one, the mass is 37 AMU. And then you would move this over 2 spots. My board is freaking out. Hold on. Don't know what's going on with my board. I did not want to write that. Okay, that's a decimal. So now I simply will multiply this, and then get my answer. And so when I get my answer, so you get 35.453 AMU. All right, let's do some examples. Our first example says we have 3 isotopes. So the fact that we have 3 isotopes, we're going to have 3 sets of parentheses with the plus sign in between. And that's going to equal our average. And we are looking for our average atomic mass. And so it's asking for that, so that's what we're going to be looking for. So our first one has a mass of 35.97. And the unit is AMU. Remember, you can put AMU, but the abbreviation for AMU, which is already abbreviation, is the letter U. So you may put AMU or U, but I do need a unit on that number, please. And then we're going to multiply that by this, but we need to make that percentage go away. The way we make the percentage go away is you divide by 100 or move your decimal over 2 spots. So that's going to be 0.0337. 0.0337. That doesn't look great. Let's erase that and see if we make that look a little bit better. Make that look a little bit better. That doesn't have a unit because we made the percent sign go away, so it doesn't have a unit. But remember to go over 2 spots. Our next one has a mass of 37.96 AMU or U, and we're going to multiply that by this percentage. But we need to make the percentage sign go away, so you move your spot decimal over 2 spots. And then the third one is you start with the mass. You can start with the mass or the percentage, doesn't matter. And this one is 90%. So would it make sense that this one's going to 90%? That our answer is probably going to be closest to this number right here. Move my decimal over 2 spots or divide by 100. You get 0.9 here. And then we just put that in the calculator. Those of you that don't have like the graphing calculator, make sure you're not doing any rounding until the end. We want to round at the very, very end. And as far as how you round, you're going to look at your masses. And because we're adding, it's decimal places. And so if we look at our masses, that one goes out 2, that one goes out 2, and this one goes out 2. So we're going to go out 2 decimal places with this mass. So this should be 39.69 AMU. So if we had 2, we would do it twice. If we had 3, you do it 3, 4, etc. They just get bigger. Depends on how many isotopes the atom has. All right, let's look at the next example. So the next example, it says that we're looking at boron, and we know that one of the percentages is 80.2%, and it has a mass, and then it has some other isotope. So it's saying it has got 2 isotopes, and we know that equals the average. But if we read this problem, notice this time they're not wanting us to find the average. They give us the average. So this 10.81 AMU is going on over here. So we know that. And so we're going to take that first one, which is 11.01 AMU, and we're going to multiply that by this, but we got to make that decimal go away. Remember, the percent go away. So we divide by 100 or move it over 2 spots, 0.802. Oh, if you want to keep the 0, if you want to keep it. All right, now the other one we don't know the mass, and it looks like we don't know the percentage either. But technically you do know the percentage, because if one of them's 80-something%, the other one's almost 20%, because percentages add up to 100. So I could go 100 minus 80.2, and I'm going to find that the other one is 1980%. Okay, because percentages add up to 100, right? And there's only 2 of them. Or if you want, decimals add up to 1. So I could say 1 minus 0.802. Most students don't like that. They'd rather do it the other way. And you would see that I would get 0.980. That's already given me the decimal number. So decimals add up to 1. Percentages add up to 100. This is the percentage. This is the decimal with the percentage taking away. So we want the decimal, but you could have done this and just move it over 2 spots. Not a problem. So that, but I don't know the mass, so that's where X comes in. If you don't like X, pick a different letter. So now we just have algebra, and prereq for Chem 1 is to be able to do the algebra. So I'm just going to do, I just noticed, that's okay. I could have put an X here, and I could have put my percentage there. My algebra teacher always made me put my X in the back, so that's what you got seeing going on there. They're just being multiplied, so it's going to be okay. So I'm going to multiply these. As I start doing my algebra, I am going to make my units go away just so I can deal with just the numbers. So if I just multiply those and do not round, you get 8.83002. That's just simplifying. And then I've got 0.198x equals 10.81. So all I did was simplify. So since x is here, I need to get x by itself. So I need this thing to go over there. And because this is being added, I would be subtracting it to the other side. You do the opposite to the other side. So that's going to make it go away over here. And I don't care that you show all your algebra steps, but if you do, I usually can find out if you've done something wrong. So this gives us, whoops, that should have been a 9 and not a 7. Let me hit undo. Should be 9, lost my page, 7998. Okay, so I'm still trying to get x by itself. This is being multiplied by x because that's what was happening in that inside that parenthesis. So I need to divide both sides by 0.9198. And you're going to get x. Let me move my paper up a little. There we go. So I'm going to get x to be, and it comes out a lot of decimals, 9 point, oh, I don't know what happened to that 9. My board did a little freak thing there. 9.9998 9, 8, I think. Well, I'm doing a mass, and so the masses should match the other masses, which means I should be going out 2 decimal places for those AMUs. So I would go out 2 decimal places, but this 9 is going to cause that 9 to become a 10, which is going to then carry 1, which is going to cause that to be a 10. So the answer really for this problem would be 10 AMU. You'd only continue to keep rounding if it's 9s. Don't do that if it's 5s and 6s and stuff. Okay? Could I check my math? Well, sure. I could take this number that wasn't rounded. I could plug it right there in for x, and I should do the math, and it should equal 10.81. If it didn't, I did my algebra wrong. Okay? But you have to take the unrounded if you want it to check perfectly. If you want it to almost check, you can put that 10 in there. All right, so that's solving for one of the mass, not the average, but one of the unknown masses. And then the third type has to do with looking for percent abundances. Now on the app, it's going to ask for only one of the percentages. For your test, I'm going to make you find both. Okay, so on the app, the homework problems, it'll tell you which one to solve for. So read the question and find which one they want you to solve for. So I'm looking for percent abundance, and I'm only going to do this with 2 isotopes. It gets a little harder if you have more than 2 isotopes. So if you're looking for percent abundance, and we can talk about why all this is about to happen, but the easiest way is just start working it. You're going to need 2 sets of parentheses, and that's going to equal the average. Okay? And so one of the things that will give you the masses of your 2 isotopes, so 62.93 AMU and 64.93 AMU. And then they told me my average, so that's going over here. Okay, so I've got that set up. So it's the mass times the percentage. I just don't know the percentage. So the easiest way to tell you, if you knew one of the percentages, let's just say one of them is 30%. Well, I know that if one's 30%, the other one's going to be 70% because there's only 2 of them, so it's 100 minus. So, but because in here we're dealing with decimals, you're going to let one of them be x, the one that they want you to solve for. So on the app, whichever one they're asking for you to solve for is the one you're going to set to be x. Okay? And the other one is going to be not 100 minus x or x minus 100. It's going to be 1 minus x. And I'm going to put parentheses around that, like that. So x and 1 minus x. If you do x minus 1, you're going to get these wrong. Okay, so first one's x, the second one's 1 minus x. First one's x, second one's 1 minus x. Okay, because the 2 decimals should add up to 1. Remember, the percentages add up to 100, but the decimals add up to 1. Alright, so now I'm going to just start doing some math here. So I'm going to go 62.93 times x is going to be x. Okay, I just took that AMU off of that. Plus, this is where we get some algebra going on. This is called the distributed property. Distributed property tells you if you've got this times a 1 minus x, you've got to multiply it by the first thing, and you got to multiply it by the second thing. So it's going to look like that. So you're going to have 64.93 times 1 is just that number, no x. And 64.93 times a negative x is a negative 64.93x. I just multiplied it by the first thing and the second thing, and then I've got to set that equal to, okay? So all I've done there is simplify that. We'll do one of these together in class, so hopefully you can get the hang of it. So now what we're going to do is called combine like terms, and I'm just going to do some highlighting here if we can see. You see how this guy has x and this guy with a negative here also has x. That thing right there does not have x. That thing over there does not have x. So I need to combine the two things that have x. So the 60, this one, without the x, is just going to come down. And if I combine those two that have x, 62.93 minus 64.93 is a negative 2x. I could even make it keep him green if you wanted me to. Let's do that. Those are the guys with x. All right. So now, well, I need this thing to go over there. Some students don't like that. They prefer to send this thing over there and then that over there because they don't like the fact that that has negative. So if you want to add the negative 2x to both sides, you're welcome to do that. So I'm not going to. I'm going to go ahead and leave that negative 2x there. But if you want, because some students don't like this negative here, they send it over there and then send that over there. It's kind of like playing Red Rover. I'm going to send that thing over there because I don't mind the negatives. So those are going to cancel. So now we've got negative 2x. Well, I've lost my green. That's okay. Let me move this up a little bit. Okay, if I do this math, I am going to get a negative here.